Okay, good day, everyone. So I will be solving some of the problems we had, or all the problems we had on the last exam. Okay, so I will start with number one. We have that a town's population has been increasing at a steady linear rate. There is a key point here. It's a linear rate. In 2015, the population was 42,500. So I can say in 2015, the population was 42,500. And then by 2019, the population has increased to 55,300. Assume that this linear trend continue. You have to predict the population in 2022. So here we can just denote this as the starting year. So I can say at 0, so we have 42,500. And 4 years later, we have 55,300. So to do this, I can just find the rate of change, which is the slope. And that is, remember, I can call this y2, x2, and this is y1, x1. So that is y2 minus y1 divided by x2 minus x1. And that is 55,300 minus 42,500 divided by 4 minus 0. Some people might use 2019 minus 2015. You still get 4, but you need to be careful when you use something like that. So if we subtract this, we have 0, 0, uh, 1 there, 13. So that is 8. 4, that is 2. Then we have 12,800 divided by 4. And that is 3,200. So it is positive. It turns out that we are having 3,200 people per year. That is the rate of increase. So by 2022, what is the population? So every year we are having 3,200 increase. So by 2022, there are several ways you can undo this. One way to undo that, you can just think that, okay, the population so in 2022, remember in 2022, so that means you are saying from 2015 to 2022. So that is 7 years. So the time is 7 years, meaning if you are growing at 3,200 every year, you want to multiply that by 7, and you want to add it to the starting point, which is 42,500. And this is 004 plus 42,500. And that is 00946. So you have 64,900 people. All right. Determine the year in which the population will reach 70,000. Now, if we look at what we have here, I did not talk about equation of that, you know, maybe linear uh, equation, or, a linear equation that model that situation. I did not talk about it. I just said, I want to find the population 7 years after. Then I said, well, it is increasing 3,200 every year. So I need to multiply that by 7. And then I add the starting point. That is when the time is 0. It turns out that this is P of, at any time t, is the slope multiplied by t plus 42,500, the starting point, right? So we want to know when, which is the question of time, when the population is going to be 70,000. So in this case, we can say P of t equals to mt plus 42,500. So we want to know when P of t will be 70,000 equals to 3,000. The slope is 3,200. T, we are looking for that time, plus 42,500. I can do some arithmetic and move things around. So that is 70,000 minus 42,500 equals to 3,200 T. If I subtract this out, 0, 0, 5, 7, 2 equals to 3,200 T. And I can divide both sides by 3,200, 3,200. Well, this takes care of this. That would be T. Double zero, double zero. So I have 275 divided by 32. So if you say your answer is T equals to 275 divided by 32 years, that's fine. That's good. No need to worry about that. If we can still go further, fine. How many 32 can we have in 275? Guys, you can just ask, how many 32 can we have in, let's say, in 270? I know that if I'm using 30 and I say, how many 30 can I have in 275? I can have 8 of that. So let me try 32 times 8. 6, 1, 24, 25. That is 256. So if I subtract that, let's see. So I will have 9, 1. I have 19 left. So that is 8. Then I have 19 divided by 32. So that is 8. So let me take this to decimal. How many 32 can I have in 19? That is 0. Then in 190, I should have at least 6. So I can just say my answer is 8.6 and I use approximately. No calculator, fine. I can still do that. I can still do that. So, but if you stop here, that is good. All right. Moving on. Problem 2. F of x equals to x squared minus 5x plus 2. We want to evaluate f of 3 plus I. So f of 3 plus I equals to, wherever I have x, I plug in 3 plus I. So squared minus 5 times 3 plus I plus 2. So if I expand this, remember 3 plus I squared is the same thing as 3 plus I times 3 plus I. So that is 3 times 3, 9. 3 times I, that is plus 3I, plus I times 3, that is plus 3I, plus I times plus I, that is plus I squared. So I have 9 plus 6I. I squared is minus 1. So 9 minus 1, 8 plus 6I. So this turns out that I have 8 plus 6. Then minus 5 times 3, that is 15. Minus times minus, minus 5 times I, 5I. Then plus 2. Then I can say this is 8 minus 15, that is minus 7, plus 2, so that is minus 5. Then I have 6I minus 5I, that is plus I. So answer. Here, I need to multiply by the complex conjugate. So which is multiply by 3 minus 4I divided by 3 minus 4I. And that is, so I do the same thing I just did earlier. So 1 times 3, 1. 1 times minus 4 times minus 4I minus 4I. Then I use this one. Minus 4I times 3 minus 12I. Minus 4I times minus 4I. That is plus 16I squared. Divided by, I do the same thing at the bottom. So that is 9 minus 12I plus 12I minus 16I squared. So that is 1 minus 16I. I squared is minus 1, so that is minus 16. Divided by, this will take care of this. So I have 9. I squared is minus 1 times minus 16, that is plus 16. So that is, for the numerator, I will have minus 15 minus 16I divided by 25. So which is, I can write it as minus 15 over 25 minus 16I over 25. I can reduce this part, so that is minus 3 over 5 minus 16I over 25. Let me be sure everything is great there. Uh, minus 1, that is 25, yes. 1, oh, no, no, no. 1 times 3 is 3. Yeah. Another something is 1 times 3 is 3. Sorry, guys. 1 times 3 is 3. 1 times, yes, that is correct. Yes, that is correct. Okay, so that is 3. So that is minus 13. So that is minus 13. Okay, so that is minus 13 over 25 minus 16. So this should be the answer. And here, well, please do not say this plus this is this. No, they're never going to be the same. No. Let us, for example, say I squared plus, let's say I squared, for example. So if you say, well, it is I raised to power 4. I raised to power 4 is 1. Okay. But let's see, what is I squared? I squared is negative 1. I squared is negative 1. So negative 1 plus negative 1, that is negative 2. So they are not the same thing, please. You cannot do that. So what can we do? We can say, let us find this. Remember, we can write this as 4 times 10 plus 3. So we know that I raised to the power 4 is 1. So which is 1 raised to the power of 10. Um, so dealing with this, remember, let's see. Let's write this way. So I can write it in this form, I raised to the power 4 times 10 times I raised to the power 3. I can do that from indices. Okay, so this is 1 times I raised to the power 3. So what is I raised to the power 3? That is I squared times I, which is negative 1 times I, which is negative I. So here is negative I. Now I raised to the power 7 is, can say 4, right? Times 1, then plus 3, which is the same thing as I raised to the power 4 times I raised to the power 3. So which is 1 times I raised to the power 3. And we just find that I raised to the power 3 is negative I. Therefore, if you add both together now, we have negative I plus negative I, and your answer is negative 2. Okay, problem 3. A drone launches a small scientific probe straight upward from a research base located on a 230-foot cliff above the fort. Because of air resistance, the probe's height above the floor in feet can be modeled by this function. At what time in seconds does the probe reach its maximum height? Well, we know this is negative, so we know the behavior. It should behave this way. So we have the maximum somewhere here, and we know we can find the vertex. Since we are plotting h of t, it means the height depends on time. So meaning that the input is t and the output is h. So if we want to find the time there, we can say h is negative b over 2a. So our b is 84 divided by 2 times a is negative 14. So that is negative 84 divided by negative 28, and that is 3. If that is not clear, just divide it, say 2 here 42, 2 here 14, 2 here 21, 2 here 7, 7 here 1, 7 here 3. So 3 divided by 1, that is 3. We need to include the unit because it is real world. So the time is measured in seconds. So we have 3 seconds. What is the maximum height? Again, we are looking for K9, H, maximum height. So we need to find H of 3. So which is negative 14 into 3 squared plus 84 times 3 plus 230. So that is negative 14 times 9 plus 3 times 4, 24, 2, 24, 26 plus 230. So 14 times 9, that is 6, 3, 9, 12. I believe 9, 6, 3, 12. Yes, so that is minus 126. So let's see, 264 plus 230, that is 494, then minus 126, that is uh, is 494. Okay. So, bring one here. So that is 8, I believe. So this is 6, and we have 368. 368. The unit is feet, I believe, feet. So we have that. Now, the next thing is to find after how many seconds does the probe reach the Cairn floor? Well, we know we are asking when the height is 0. So, which implies that we need to find negative 14 t squared plus 84t plus 230. We need to set it to 0. So, what can I do? Well, I can reduce this to maybe divide through by 2, but that is not even necessary. If I have a situation like this, I just need to say t equals to, use the formula method. Don't try to find the factors. That will waste your time. So just do this. B squared minus 4ac divided by 2a, because this formula always works. So minus b is 84 plus or minus b is 84 squared minus 4 times a is negative 14. C is 230 divided by 2 times negative 14. Okay. So that is equal to minus 84 plus or minus square root of, let's see, 84 squared, that is 84 times 84, 16 remain 1, 32, 33, 8 times 4, 32, 3, 64, 69. So we have 6, 5, 2, 7. So I have 7, 2, 5, 6. Minus times minus plus. So I need to do 4 times 14, that is 64. So I need to multiply 230 by 64. All what I need to do is to multiply 230 by 64. So that is 2, 1, 9, 8, 1, 3. So 2, 7, 4, 1. Then that's 0, I put it here. So I have 14, 720 divided by negative 28. So that is negative 84 plus or minus. If I add those two numbers, I will have 14720 plus 7256. So I will have 6, 7, 9, 1, 2. Square root of 21976. If everything is correct, should have that. Anyway, so if you stop here, I don't expect you to stop here. Actually, you should be able to analyze what we have. Look at these folks. There is a negative here. There is a negative here. Whatever this value is giving, so I will have minus 84 minus whatever that is, and dividing by negative 28. So my answer will be positive. Now, if I also think square root of 21,976, is it going to be more than 84? Is it going to be more than 84? So the answer is yes, because 84 times 84 that we did the other time is 7256. So it is going to be more than 84. So it means I'm adding negative 84. Sorry, I'm subtracting 84, negative 84 from a number that is bigger than 84. That means it will be positive. The numerator will be positive, and I'm dividing by a negative. It means the whole answer will be negative. And now, time cannot be negative. So it turns out that my answer should be negative 84 minus square root of 21976 divided by negative 28 seconds. Answer. That is what you should be able to do in this class. You should be able to do that. Okay. Is the teacher expecting you to know these two, decimal? No. But you having this is really good. You should be able to find that. Okay. All right. This problem. How long is the probe at least 300 feet above the can floor? Give the interval of time during which, see, I even put it here. That is what the question is asking you. How long is the probe at least 300 feet above? At least, that is, it is up to 300 or above, meaning set the height. What is the height again? Negative, we are asking when is negative 14t squared plus 84t plus 230, when is it going to be greater than or equals to 300? You have it here, straight in front of you. So just solve this. To make my work easier, I can multiply through by negative. I don't want to have negative on that 14. So if I multiply by negative, I will have 14t squared minus 84t minus 230 minus 300. Now see, I need to change this because now I multiply through by negative. Remember the rule for inequalities. It will change. Now, I can bring 300 to this side, so I have 14t squared minus 84t minus 230 plus 300 less than or equals to 0. So what do I have? I have 14t squared minus 84t plus 70 less than or equals to 0. I can divide through by 7. Let me try with 7. I can divide 14 by 7. I should be able to divide 84 by 14. So 7 here 2, 7 here 1, remain 1 and 14, 2. 2 here 1, 2 here 6. So that is t squared minus 6t plus, how many 14 can we have in 70? That should be 5, less than or equals to 0. Right? So all what we need to do at this point, you can factorize if possible. You can, let's see. So that is t. Let's see if we can do that. So that is 5. So that is two numbers. That is 5 times 1, negative, negative. So that is minus 5, t minus 1. So we have t minus 5 is less than or equals to 0. T minus 1 is less than or equals to 0. So we have t is less than or equals to 5. T is less than or equals to 1. Now, T is less than equals to 1. Look at that. T is less than equals to 1. T is less than equals to 5. What do we know about? Okay. We are looking for how long the probe at least 300 feet above the floor, 300 feet above the floor. Give the interval. So look at this. I can say the interval of time during which the height is greater than or equals to 300 is, can I say it is between 1 and 5? Um, between 1 and 5. So let's see. C is, so this is fine. T less than equals to 1. So that is, so I can just say between 1 and 5. Between 1 and 5, right? From 1 to 5. So that is cool. At least for our case, that is good. All right. So one thing I want to talk about is, there is this idea you can take, some value, say a number that is less than 1, say 0 0.9, 0 0.5, and you test, you put it in the height, and you put it there, is it going to be more than 300? So you check that, but I just don't want to add to that. So it's just leave it that way. Because if you put one here, if you plug in one here, that would be negative 14. Plus, if you plug in one here, that would be 84. So minus 14 plus 84, that is 70 plus 230. So that is 300, right? So one works. So, and so on. Okay. Let us move on to this problem. Oh, I believe we had a problem like this in class. And this is similar to even problem 1 in a way. It is similar to problem 1. We are having that when the price is $24, we have 19,000 people attending the concerts. And when it is $20, then we have that increase to 27,000. We can find the slope. So the slope is 27,000 minus 19,000 divided by 20 minus 24. So that is minus 8,000 divided by, no, this is not minus, that is positive. 8,000 divided by minus 4. And that is negative 2,000. So that means we're having this per dollar. So it means that for every $1 increase, there is a reduction of 2,000 people attending the concert. That is the meaning of negative. It doesn't mean human beings can be negative, but since it is rate of change, it is saying for every $1 increase, then there is a decrease of 2,000 people attending the concert or getting the tickets. Now, assuming that the attendance is linearly related to the price, the attendance is linearly related to the price. Again, like we did the other time, we can say, now we can say we know the slope. Remember, we can say A of t. Here, let's A represent, no, not t. It doesn't depend on time, it depends on price. Represents the attendance depending on price. So A of P, I will use P, not T. A of P, remember we were told that the attendance is linearly related to the price. So that is how I know that it depends on price. And also from what we have here. So A of P, the slope times the price plus B or C. That B is the y-intercept. That is when the attendance is zero. I mean, sorry, when the price is zero. So we know that A of P is negative 2,000 P plus B. Now we need to find B. All what you need to do is pick one of these 2 points. So let us use 24,000. You can use any of them, just a point from the 2. So that is A of 24 equals to negative 2,000 times 24 plus B. So A of 24 is 19,000 equals to minus 48,000 plus B. And then we can find B. So B is 19,000. And we move that to the other side plus 48,000. So B is 0.00076. So 67,000. So that means our attendance, that formula, that model attendance, depending on price, is negative 2,000 P plus 67,000. So I just did exactly what we did on problem 1 here, what we did here. The only thing is that it was easier because I already considered the time, because this is time. So I consider this starting point as 0. So I just use this as my B. I hope that makes sense. You can still do this part the way we just did that now. So just pick one of these 2 points to find your B. Then in the end, you see that you will get 42,500. Okay, now what do we know? What do we need to do? What ticket price would maximize the arena's revenue? So how do we find revenue? How do we generate revenue in our business? Revenue in this case will be the unit price multiplied by the number of people that attend the concert. That is how to know the revenue. Real world, just as when you are doing business. the unit price multiplied by how many number of people do we have attending the concert. So that is P times, remember we have already modeled A of P to be negative 2,000 P plus 67,000. And now we can say this is negative 2,000 P squared plus 67,000 P. So that is revenue that depends on P. Now, our question is to find the ticket price that maximizes the arena's revenue. That is, I'm graphing revenue which depends on price, revenue against price. And I expect to have this. How do I know? Because look at this. This is negative. So I know it is going to behave that way. And at this vertex, the input is P, the output is revenue. So that is my vertex. So I can find that ticket price that give me this maximum revenue. And to do that, we know what to do. So P equals to minus B over 2A. So which is minus, our B in this case is 67,000 divided by 2 times negative 3,000. So that is negative 67,000 divided by negative 4,000. And that is negative will cancel negative, 3 zeros, 3 zeros. So I have 67 over 4, which is 4 in 6, 1, remaining 2. 4 in 27, I have 6, that is 24, remaining 3. 4 in 30, so 4 in 3, not possible, so I put points. So in 30, 7, remaining 2, so 5. So my answer is $16.75. $16.75. So that is the price that maximizes the revenue. Folks, what we have done here is not bad at all. We were told that, look at it. This happens to us maybe when you go to see movies and you say, okay, when the price is so, we have this number of people. If we increase that price, then automatically the number of people that we attend will drop. Then we can use that to model if we are sure, as we know here, that we assume that the attendance now, because someone might ask you, what if the price is $32? What if the price is $50? So we know that, okay, let us model that. So we assume that the attendance is linearly related to the price. So now we try to figure that equation out, which is under linear equation. If you've forgotten linear equation, go and play the video again and remind yourself how to generate this equation. So we have mx plus c, which in this case we call mp plus b. So we find b, we know our slope already, and our b is 67,000. And then we just use the fact that revenue is unit price multiplied by the number of attendees. So, and we've already modeled this guy using this. So we just put it there and we expand this. And now we have a quadratic. And we know if this is negative, it is going to behave this way. And we have maximum here. And then when we have the maximum, the price is the input. So that would be the price that maximizes, that gives this maximum revenue, right, guys? So, and that price is 16.75. Because you see, this is the beauty of maths. This calculation let the business owner know that, well, selling it at $24 is not the best, or even at 20, it's not the best. The best price is not even when you say, okay, let's do it at $10. Are you going to make more money? So math allows us to know the price at which we are going to have the maximum revenue generated. And that is when you sell your ticket at $16.75 for this business. Now, the question here, what is the maximum revenue generated? See, guys, you've already known the price, the price that maximizes the revenue. So what you need to do is ask yourself, what is the formula for revenue? Revenue that depends on P is negative 2000 P squared plus 67,000 P. So the price that maximizes that is 16.75. So meaning we are looking for R of 16.75. So which is negative 2000 times 16.75 squared plus 67,000 times 16.75. Guys, this is what I expect you to do. And you just leave it here. Just leave it here. No need to start, you know, um, wasting time and saying 16.75 squared. The reason I know I can leave it there is because that is my final answer. I'm not doing anything again. For example, because I still needed this value. So I, forced myself to get to that final answer. But I don't need this again. So I just input the value there and I leave it there. You're fine. That is the calculus there. So you've done it and it is fine. If you have calculator, if you're allowed to use calculator in another math space, then you can go ahead and compute it. That is why if you just input this in your online homework, it's not going to complain. It's going to grade it for you because you've already done the work. Okay, problem 5. Use the graph below to answer the following questions. Determine the least possible degree of the polynomial function. Well, we can see this graph is actually tricky. We have intersect here, intersect here, intersect here. We have 3 turning points. We have one here, we have one here. I won't call this a turning point because a turning point is a point where your graph is increasing, and at that point, hold on, you have a curve like this, it is increasing, and at some point, it starts to decrease. So we say that is a turning point. Or it is decreasing, and at some point, it starts to increase. So we call it turning point. But in this case, this graph is increasing. At this point, it continues to increase. So that is not a turning point. We have a special name for that when you get to that map. Okay. But what can I do? Well, there is another thing you have learned. Look at this intercept. Can you think about the multiplicity? It touches the x-axis and bounces off. It feels like I'm going to have 2 there. It is degree 2. So I have something like x plus 1 raised to power 2. What about here? it behaves like this. That is cubic. So it feels like I will have x minus 2. The 0 there is 2. So x minus 2 raised to power 3. This behaves as a line. So that is x minus 4. The 0 there is 4. So raised to power 1. Remember, multiplicity is the addition of all the, degree is the addition of all the multiplicities. So 2 plus 3 plus 1, 6. Done. That is that. So if you want to, let me write this very well. I can say x equals to minus 1 is a 0 with multiplicity of 2. X equals to 2 is a 0 with multiplicity of 3. X equals to 4 is a 0 with multiplicity of 1. So least degree is 6. So you see, using the intercept is not enough, or the turning point, because that will not give us the real stuff here. So we use the multiplicity idea. So maybe the question you have is, do you need to check all these things? Yes, check it. That is why you have all these tools given to you. Here I said discuss the end behavior. Well, end behavior, what I'm asking you is, as x goes to negative infinity, that is, as your x goes here, negative infinity, where does your y go to? You see your y keeps dropping. So it means f of x goes to negative infinity. And as x goes to positive infinity, your f of x. So as x goes to positive infinity, your x keeps going down. So f of x, your y. So f of x is negative infinity. So that is that. Then I ask, discuss the global extreme values, the global max and global mean. Remember global max. In this case, we have global max. This guy end behavior, it will keep going down. It never comes back up. So meaning that whatever we have here is the global max. So like this is our global max. So yeah, I would just say something like maybe 4.2 or something. So 4.2, I would say approximately. And that occurs at x equals to, what is the value of x? Also not, maybe 3.6 or something. Approximately 3.6. That is where it happens. Global mean does not exist. How do I know? It keeps going down. Look at the NBA, it keeps going down. It never ends. It never ends. So I know it does not exist. So that is that, guys. Here, I ask you to write a formula. Given the graph shown below, write a formula for the function. Well, many of you know that, well, we have intercept, x-intercept all through there. So meaning I know the zeros, that's what it means. And I can say f of x equals to, let me generate a factor. So x plus 3, x plus 1, and x minus 3. Here, it passes through as a line. So the multiplicity there is 1. Again, as a line, multiplicity is 1. Here, as a line, multiplicity is 1. So, but there is one more thing I need to consider. I need to find the coefficient A. And to do that, I need the y-intercept. So when x is 0, y is 2. So I just need to say 2 equals to A into 0 plus 3, 0 plus 1, 0 minus 3. And that is 2 equals to A times 3 times 1 times negative 3, which is negative 9A 2. And that implies that A is negative 2 over 9. Therefore, our function, just like we did for the, just like we did in class. So that is minus 2 over 9, x plus 3, x plus 1, and x minus 3. Answer. That is it. Okay, next problem. Find the intercepts, zeros, and multiplicities, the multiplicity of the following polynomial. Well, this is x raised to power 3. It means something. It means x minus 0 is a factor, or x equals to 0 is a 0. So x equals to 0 is a 0. Remember, x cubed can be written as x minus or x plus 0 raised to power 3. So that is why I claim x equals to 0 is a 0 with multiplicity 3. X equals to 1 is a 0 with multiplicity of 3. 3. And x equals to negative 2 is a 0 of that polynomial with multiplicity of 1. So the question is that we should find the intercepts. Well, x-intercepts quickly. That would be 0, 0, 1, 0, 0, 1, 0, and negative 2, 0. So we know the x-intercept, right? What about y-intercepts? Y-intercepts, we know that we need to find that when x is 0. That implies that go back to your formula, plug in 0. If you plug in 0 there, y will be 0. So that is y-intercept. Let us see if we've answered everything. We find all the intercepts, we find the zeros, we find the multiplicity. So we are done with that part. Okay, use the information from part A to graph the polynomial function. Yeah, so let us do that. We know that our x-intercepts, we have x-intercept at 0, meaning that the graph passes through that point. It passes through 1, and it passes through negative 2. We know that. Y-intercept happens to be same point where we have x-intercept, so no problem. Now, What do we do? We need to do something. Let us study the end behavior because we need to know, is our graph this way? Sorry. We need to know if our graph is this way or this way. We need to know. Now, how do we know that? Add all the multiplicities together. The degree is 7, which is odd. Do you remember that? It is odd, which means it is going to behave this way. It will start somewhere in the negative and end somewhere in the positive. And since we have positive here, so I know it is going to behave that way. If we have negative here, then I know it is the other way around. So, okay. So this is my pursuit. Now, how can we generate that? I know I'm starting somewhere here, I'm ending somewhere here. That I know. And I do know that my graph will pass through these points, and this point. The question, one more question I need to answer is how? At -2, it passes through it as a line because the multiplicity is 1. But at the remaining 2 points, it passes through those points as cubic. That is interesting. So I do know that my graph will pass through this point, go somewhere up, and it must behave this way. And also at this point, it must behave this way. Right? Let me do that very well. Yeah, I know that. So I can do this. Then I know here it goes as a line. I can do this, and I'm done. The question you might ask is, wait. How do we know where to turn here? How do we know where to turn here? That is simple. If you give me this, I will give you your full mark. But then, for such curiosity, we can find that all what you need to do is, we know that f of x is given as x cubed times x plus 2 raised to power 1. I have it here. Okay. Plus 2 raised to power 1, then x minus 1 raised to power 3. All what I need to do, guys, is let me evaluate f of 1. F of 1, so that is 1 cube, 1 plus 2, and 1 minus 1. What is that? Let me see. X. Oh, sorry. I made a mistake. Not 1. Yeah, because that wouldn't make sense. It is -1. I'm picking. See, guys, here is -1. So that is, I will go again. -1 raised to power 3, -1 plus 2, then -1 raised to power 3. So that is -1 raised to power 3 is -1 times -1 plus 2, 1 times -1, that is -2. -2 raised to power 3, that is -8. So that is +8. So that means if this is 7, so that means 8 will be somewhere here. It turns out that I can do this. So you look at these guys, can go up. That. Can we also do the same thing here? Yes. All what you need to do is let us find f of 0.5, for example. So which is 0.5, which is 1/2. So maybe we should use fraction, which is 1/2 raised to power 3 times 1/2 plus 2 times 1/2 minus 1 raised to power 3. So that is 1/8 times 5/2, 2 plus half, that is 2.5, 2 plus half, so that is 5/2, times -1, so that is -1/8. Half minus 1, that is -half, raised to power 3. So we have that. So I will have -5 divided by 64 times 2, 128. So 5 divided by 128, that will be very small. That will be very small. That will be very, very small. Not up to 1. So I can just do, but it is negative anyway. So uh, one sec. Oh, shoot. Okay, I need that back. So I can just do this. Okay, anyway. So I want this place to be a, don't forget. So I can just turn. Oh, that's not perfect. So something like that. It doesn't have to be perfect. You are using freehand, but in case you want to know, how do you know when to turn? So just do that. But like I said again, if you just do what you did the other time, if I see this, um, and you know, at 0, you make me see that you have considered that, and at the turning point there, you do this, that is fine. That is fine. That is fine. It's just a sketch. Okay. That is that. And the last problem, I believe, find the O's or the points of removable discontinuities. We do not have same factor in the numerator and denominator, so we claim here none. Done. Find all the vertical asymptotes. So meaning set the denominator to 0. So meaning we have x plus 2, x minus 2 equals to 0, which implies that our VA will be, that is vertical asymptote to the x equals to -2 and x equals to 2. This one with multiplicity of 2, right? You can see. Then this one with multiplicity of 1. Find the horizontal or slant asymptotes. Well, here we have x, we have x, we have x. So that is x raised to power 3. Here we have x squared times x. That is x raised to power 3. We have a situation whereby they are the same, they have the same power. So we study the leading term, which is x over 3 to x over 3. And that is 1. That turns out that is 1 over 1, 1. So meaning y equals to 1 is our what? Horizontal asymptote. Done. Find the x and y intercepts. Well, for y-intercept, what we need to do is to set x to 0. So if we go here and we set x to 0, so we have f of 0 equals to 0 minus 1, 0 plus 4, 0 minus 5, divided by 0 plus 2 squared, 0 minus 2. So we have -1 times 4 times -5 divided by 4 times -2. And that is -20 divided by -8. So that is 5/2. Let me see. 4 here 5, 4 here 2. Yeah, so 5/2. Now, what x-intercept? So y-intercept, sorry, y-intercept is 0,5 halves. Now, x-intercept, we need to set y to be 0. Or if you follow the graph, our work on rational function, we can also say it means set the numerator to 0. So that is, if we set the numerator to 0, that is x minus x equals to 1, -4, and 5. 1, -4, and 5. So our intercept will be 0, 1, 0, -4, and 0, 5. Let me be sure that this will be up. Yes.